Hello, Angie. How we doing? What is this? Yes, hello, Angie. Are we doing outstanding? I hope you're doing good this evening. Good evening to you. Good afternoon / evening to you. I hope we're doing well today. Bring up these two guys here. I'm going to need them some capacity today. Go. Righty. All right. Hey, there's Beast coming on in, second stream. Hey, thanks, my friend. Thanks. Good, I'm doing good. I'm doing good. Just getting prepared a little bit for today. But nothing too major going on here. Just sitting, chilling, having a good time. I'm sure, hopefully, that you're having a good time yourself today. I don't know if this is your last class of the day, Angie. But, not mine. I know that. I got one more tonight. But still. Hopefully this is your last class of the day, and then you'll be having a nice time sitting and chilling and having fun for the weekend. So, really quick, Angie, did you get my email? I sent the class an email about the due date there. Were you actually able to receive that? Guess I'm just checking to see, making sure that that went through. It's my last class, but I get a bunch of homework. I know. I know. Oh, yeah? Okay, good. So if you got it, then everybody else probably got it as well. So I made sure to do it all through D2L so it went to your appropriate email address. Usually your Elgin one, but you never know. Whatever it is, it doesn't matter. As long as it went over to the appropriate address, then that's okay. Then I can feel a little bit more secure, saying that yes, she did get that done, and I'm very happy. All right. Got any plans for the weekend there? Hopefully, I don't know who's got plans for the weekend, but I got lots of plans for this weekend. We're at 3 a.m. So, what are you doing awake at 3 a.m.? Holy smokes, really? Oh my goodness. 3 a.m. Oh no. Good evening, Hisa. How are you doing? I turned around and slept peacefully knowing I'm caught up. I have no idea what you're doing at 3 a.m. I can't answer that question. Pretty sure I sent it before 3 a.m. I think. I was up pretty late that night, I think. I was doing some extra work that I had to get done. Oh, man. I'm very good, I'm very good. Just talking about how this weekend's going to be pretty busy. So, at least for me, it's going to be pretty busy. Lots of things to do in the next few days. Be out and about for this weekend. Usually I'm just kind of a homebody, but man, people are clamoring for me here. I'm playing Jackbox with some friends. Fair enough. Yeah, my sister surprised me. She's taking me out to the Bears game on Sunday for my birthday. So it's a really nice gift of her to give me. I'll be going out to Soldier Field and having a nice time. Hanging out with my sister. Actually, I'd be hanging out with my sister most of this weekend, so be having dinner with my sister and my mom tomorrow. So, oh, thanks, I appreciate that. I'll be turning. My birthday is on Monday, but Monday is a school day, so yeah, I'm gonna be pretty busy in the weekend before. And my other cousin's birthday is actually like on the 18th. So it's it's pretty crazy. I don't advertise too much about it. It's just like, okay. It's just another day around the sun, folks, for me. Okay. Be turning my ripe old age of 42 this year. Well, it is what it is. Thank you, Anna. I appreciate that. Thank you, Tori. I appreciate you. Thank you, Julie. Appreciate you. Thank you, Angie. Appreciate you. I we get to have a little bit of, usually, like, I know everybody says birthday's super important. Like, man, like I'm just happy I could go out and have a nice dinner with some family and just kind of enjoy things. I know it sounds super old fashioned, but when you get to a certain age, it's like that's all really birthdays boil down to at that point. It's like if I can enjoy a nice dinner, that's cool. I'm down with that. Football tickets were out of nowhere. Thank you, Skinny. Appreciate that. Thank you. That's really kind of you to say. Super kind of you to say. Appreciate that. Just another spoke in the wheel, man. That's all I am. But it would be nice to go out and go out to the first Bears game of the season. Thank you, Gally. I appreciate that. Thank you very much. I appreciate that. All of you guys are super nice. You guys are super nice to me. I don't know. I don't know if I deserve that, but you know what? Thank you so much. I appreciate it. Ready to do some go from birthday wishes to talking about mathematics. You're like, oh man. All right. Okay, ladies and gentlemen, we got oh my goodness. I know you're like, why? I'm like, okay. That's fair. All right, let's let's do this, ladies and gentlemen. We're gonna hopefully get stuff done here today. I'm hoping that we can get stuff done here today. Let's go ahead and do it here, ladies and gentlemen. No, I'm not ready for math. I'm sorry. I'm sorry, Angie. We gotta do it. All right, let's do this. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, ladies and gentlemen, we're going to continue moving forward here in Chapter 5. All right, so last time we just did the first section of Chapter 5 talking about probability. So that was what we kind of did here. Last time we talked about the basics of probability, did a few examples there, took it pretty easy, got stuff done, moved on, good stuff. Today, we're going to be continuing doing the same things, just with a few new concepts, of course, thrown into the mix. And honestly speaking, at least the concepts that we talked about here in the first section of probability I don't think people had a tough time with that. I'm hoping that today will hopefully be the same. All right, so hopefully it'll be just much of the same thing. So we're going to be talking about today compound events and some general addition rule stuff. And we'll be talking about mutual exclusivity and complements, along with possibly other things as well. So let's do. Kind of like the uncertainty. All right, let's go to the big board. Big board. All right. So going to the big board here, we're going to pick up where we left off, which was question number 8. Question number 8 on the handout here. So let's talk about it. Question 8. What is a compound event? Okay, so we talked about events last time, and events were like if we took our die and we rolled it, and we got, we rolled a 4, that was an event, okay, or, whatever we did with like a 6-sided die or anything of that sort. So anything that was like, okay, that was an event. Now, we could talk about what's called compound events, which are basically 2 or more events that occur, okay? So if there are 2 or more events that occur, then that's what we call a compound event. So again, rolling the 4 or 6, not and 6, but 4 or 6 is a compound event. Okay, so rolling the 4 or rolling the 6. Okay, on our 6-sided die. There you go. Now, we're going to have two types of events. When we talk about compound events, you're going to find out that you have kind of two things kind of going on at the same time. So let's talk about determining what the relationship is between both of those events, or the multiple events possibly. So the first type that we could have here are what we call mutually exclusive or disjoint events. So what does mutually exclusive or disjoint mean? This means that both of the events, or the two or more events in this case, have no outcomes in common. So if I roll that 6-sided die and I roll a 4 or a 5 or a 6, well, none of those three rolls have anything in common. All right, there's no overlap between rolling a 4, rolling a 5, or rolling a 6, because those happen to occur. I can't speak today. Those happen to occur separately, okay, and independently. Okay, so the way it works is, if you can see here on screen. Actually, see if I make this slightly bigger. There we go. All right, it says number 10, what is the general addition rule? So if we have mutual exclusivity, this would mean that if we take the probability of A or B, 4 or 5, for example, that means we just go ahead and add up their probabilities together. So the probability of A plus the probability of B. However, let's say they're not mutually exclusive. Let's talk about that. I'll describe what this means here. If they're not mutually exclusive, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And again, what we want to do is take away the double counting here. That's the probability of A and B. Now, what do you mean by that? How do I look at that from a point of view that's a little bit easier to kind of comprehend? So let's go back to our paint tool here. All right. So to kind of get this down, and at least to understand how it works, it's actually pretty simple, but figure, hey, do it out here. So let's say we have a circle here, and we will call this circle, we'll call this A. Okay, so this black circle here will be A. This will be event A. Let's say I have another circle here. Put it as another black circle here. Let's say I have this. All right, there we go. And let's say I'll put this in red here. Let's say this is event B. Now, you've probably seen this before. These are the good old classic Venn diagrams you probably saw back in the day replay. All right, so this is event A and this is event B. Now, if they are indeed, make this bigger. So if these two are indeed separate, then these two circles would be separated from each other. Okay, they'd be two separate things. If they have something in common, however, that's this middle part right here. So you can see here on this picture, we have a middle part. All right, I'll label this in purple. We have this whole middle part here. Okay, now this whole middle part here specifically is A and B. Okay, so this is all A and B. So if you notice here, just based on this simple picture, we can count everything in A and we count everything in B, but notice that we counted this middle portion here 2 times. So because we counted that middle portion there 2 times, then that means we need to get rid of one of those countings here, and that's why we subtract by the probability of A and B, is to remove one of those countings. So it's like, again, I counted up the whole circle of A, and then I counted up the whole circle of B, but I counted this purple portion 2 times in order to do so. All right, and that's essentially how that worked out. Okay, so it's not super hard to see, but again, just based on a simple picture, there you go. Should be easier to digest. Now, to be fair, you're like, well, where am I going to use this? How is this going to be useful? where is this going to be, applicable? I said, all right, I totally agree with you. All right. So let's take a look at an example here. Let's use it, and we'll see exactly how it works. All right. So I'm going to use the textbook for this. And all right, here we go. Alrighty. Okay. So I don't know if you guys can see that or not. I hope you can. Excuse me. Can you see this table here for number 40? We're gonna answer questions using that. But everybody can see number 40, at least the table for that. Just say yes or no if you can see that or not. Yes? Okay. Alright, cool. A little worried there for a second. Not sure if my screen's like. Alright. Alright. So, let's take a good look here. We have some working couples. Alright. So let's take a good let's look here, and then you guys can answer some of these probability questions based on this table that we see here for number 40. Okay. So here we got, again, a guidance counselor in a middle school collected the following information regarding the employment status of married couples within his school district boundaries. So again, we have the husband, we have a number of children that they have, okay, 0, 1, 2 or more kids, okay, husband only, wife only, or both spouses, all right, in this particular case. All right. Now, let's look at letter A. The probability that for a married couple selected at random, both spouses work. So let's find out what is the probability that both spouses work. Let's take a look here on how we can break this down a little bit further. If we're trying to figure out the probability that where both spouses work, we want to figure out how many spouses work out of the total number of people that we ask, okay? So in this case, how many spouses work according to the table? How many according to the table where both spouses work? And how many people did we survey? Anybody tell me here? How can we figure out this probability? Probability where both spouses work. Okay. So we get 1,149 people, okay, where both spouses work. And out of how many people did we survey there? Oh, how many people did we survey? Oh yeah, just be a little careful there, Angie. Fine. 1,700. Okay, good. So again, let's break this down one more time. We did talk about this last class, but again, at least we can use this table here appropriately. Okay, so first of all, just as a reminder here, 1,149 people is where the total of both spouses working. And then 1,700 is the total surveyed. All right. So I'm just justifying where both of these numbers had come from here in this instance. All right. Can anybody give me a decimal? We'll go to 4 decimal places just as usual. Give me a decimal here for this particular probability. 1,149 divided by 1,700. .6759, okay? All right, let's put it down. Be sure to round up there, Hisa. Remember what's next to the 8 there. Okay. All right, good. So far, so good. All right, let's look at the next one here. And then hopefully this will start to make a little more sense here. Okay, letter B. So we start off with something easy, just easy probability. Hopefully remember this from last time. Let's start with letter B. Where's the probability that for a married couple selected at random, the couple has one child under the age of 18? Actually, I'm going to skip that one. Under the age of 18 is, that one's same. All right, let me go to C because I do want to look at this. All right, what is the probability that for a married couple selected at random, the couple has 2 or more children under the age of 18 or both spouses work? All right. Now this one I do want to look at here. We have 2 plus or both. Okay. Now, here's the way it's going to work using this rule, this general addition rule. All right. If we want to find the probability of having 2 kids or more, all right, or both spouses work, we want to split this up into 3 parts. We're going to have the probability of 2 plus kids plus the probability of both spouses working, but we need to go ahead and subtract by the probability of 2 plus and both. Okay. Are there any questions about that so far before I move forward here with the actual numbers? Any questions about that so far? And I want to be sure everybody's on the same page here, so just let me know if we're having issues. All right. Okay, so let's take a good look here. What's the probability that we get 2? What's the probability that we have 2 plus kids in this survey? Tell me the probability of 2 plus kids. What do we have here? What's the probability of 2 plus? Having 2 or more kids according to this survey here. Can anybody tell me? Just give me a fraction. It's fine. Figure out the decimal at the end. All right, 559 out of 1,700 is correct. Right. So we have 559 people. Again, look at the table here. The total of 2 or more kids is 559, according to what we see there on the table. All right? So that isn't too bad. I'm going to take that over the 1,700 total overall. All right, so far so good. We'll come back to that momentarily. All right? Let's take a look at the probability of both. Well, the probability of both we found in Part A, so we're going to go ahead and copy that one down. Because we already know that from Part A, that's going to be the 1149 over 1,700. Now again, this is not where we stop. If you accidentally add only these two, well, you could end up with a value that is higher than 1,700. And if you do end up with that, well, then you know you went wrong somewhere. You may need to do something extra. Like in this case, well, we're going to need to. We're going to take the probability of 2 plus and both. So what's the probability of having 2 or more kids and both? The probability of 2 plus and both. So based on what you see on the table, what is that probability going to be? 2 plus and both. Now take a look at the table there on the left. You guys think? 370? 370 out of what, Gioma? 370 out of 1700. Okay. That's correct, Angie. All right. All right, so let's take a good look at this. So 370 out of 1700. Let's explain what's going on here. Okay. Let's look carefully. Notice, I want you to notice here again, the wording here. We talked about wording last time and how important it was. But once again, wording is going to be highly important here as in this example as well. We want 2 plus and both, okay? So we first look at 2 kids. So here's the column for 2 kids or more, okay? So these 3 guys. But then we also have to have both spouses working. So it's going to be this row here where both spouses work. And we have 2 or more kids. So they line up right here at 370. So 370 out of 1700 basically are 2 plus kids and they both work. All right, so that's how we come up with that part right there. So you notice what we see here is we see 559 plus 1149 minus 370. And remember, we're going to put that all over 1700. So you know what? I'm just going to go ahead and start here. Just for the sake of the example here. Okay. And so we go ahead and do that here. What that is, off the top of my head. Uh, 370, sorry, I put 330. My fault. Should be a 7. Sorry, that should have been 370. I accidentally put 330. My fault. So we got 1338 over 1700. And can anybody give me a decimal for this? What's the decimal for this? Yeah, I was wrong, Angie. Sorry. It was an accident. .7871. Okay, good. All right. All right. Okay, very good. Any questions about that? Any questions so far? Again, type no in the chat if you have no questions, or if you do have a question, please type out your question. All right. Okay, good. Let's go ahead and answer letter D here. And then this time I want you guys to go ahead and give it a shot. Okay? Let's give it a go here. Let's look at letter D. What's the probability? Look at the probability here. The probability that for a married couple selected at random, the couple has no children and only the husband works. Okay, so the probability of having 0 kids or the husband only works. All right, so tell me how I would set this problem up here. How would I set this problem up here? Is your Twitch profile the pillar of creation, or was it the horse head? Actually, neither. That is the hand of God. Well, okay, I don't want to lie to you. You asked the question, to be fair. Tell me how I could solve for this here. Probability of 0 or 0 kids or husband. Tell me how I should set that up, guys. What should I do? What do I do, ladies and gentlemen? What do I do? So P of 0 or husband. Guys, I'm gonna wait for you guys to tell me, because I'm just gonna wait for you guys to tell me how am I going to set this up here and then solve for it. Like, I don't need the answer right away, just tell me how I should proceed. I'm going to use this properly. If you're not sure, then just write you're not sure. But hopefully that the previous example will give you a little bit there. All right, the probability of children and the husband works, okay? Is that it? Probability is 0 plus the probability of husband. Do we have, is there anything in common? So think of it this way, guys. Remember, if they're mutually exclusive, that means that there's nothing in common between them. Is there a number in common between them? Yes, okay, there you go, Julie. That's correct. There is a number in common between them here. So we're also going to subtract off the probability of 0 and husband. Okay, does everybody see where I'm coming from on that? Any questions about that? Again, these are not mutually exclusive here, so therefore we do have to subtract by that last amount there. We will get to that part. Okay, where are we confused here? Let me know. I don't mind explaining that part again. Absolutely. Please ask a question. Look, I'd rather have you guys ask away and then have you guys understand what I'm trying to peddle. Ask as many questions as you guys like. I don't mind. All right. So I want to go back to let's go back to the notes here for just a second. Okay. Okay. Where are we getting 3 sets of numbers if there's only 172 and 788 that fall into those categories? That's a good question here, okay? So, again, we're going to have underneath the general addition rule. In question C is a couple with 2 or more children and both spouses work. Oh, does it say that and? I probably answered for or then. Oh, it does say and. Okay, I thought it said or, and that's I kind of went with or there. But it would if it's and, then it's basically just the 370 over 1700 would be correct there, Chioma. So if we were to just look at that as a microcosm of a question, it'd be 2 plus and both. It'd be 370 over 1700. So that does help us out here, admittingly, Chioma. In relation to your questions, it does help us out here significantly for Maybe not that number, but the idea helps us out for this next question here. Correct. Yes, that's correct. I just accidentally read that part wrong, but the idea is going to be the idea, at least looking at the difference between the wording, is important. So that's why if this read or, then I'm taking it the same way that I did this part D part. Now, to answer your question, Angie, let's talk about that. The three sets of numbers here is 172 and 788 fall underneath those, excuse me, those categories. Now, you need to look at it from this perspective here, Angie. Let's talk about it here. So if I said, all right, how many people are in the zero category? Okay, so let's forget probability for just a second. Okay, let's try and take it one step at a time, guys. Okay, so let's look at one step at a time. All right, how many people are in the zero category? Well, if we look at the table here, how many people are in the zero category? That's going to be the 788, right? 788. Okay, so we can take that to the bank. All right. Now, how many people here, Angie or anyone else, are in the husband category? How many people are in the husband category? Because we're trying to find zero or husband. So 172 people, no. That's not correct. The husband category, again, going straight across here, Angie, is 425. Do you see that? It'd be 172 plus 79 plus 174. So in the husband category here, that's the 425 for just the husband part. Okay? Do you see that? I'm looking at the totals here for these two guys. What's the total for the zero category? The total was 788. That's what you told me, right? What was the total for the husband category? I want the total for that. What's the 425? Okay. We good? We good so far, Angie? Everybody, I hope you're good. I hope you're good with that. I hope you see where I'm coming from with that. Okay. Now comes the last part here. We're going to subtract specifically by the amount of zero and husband. So how many people are both in the zero category and the husband category according to this table? How many people are both in the zero category and the husband category? 172. That's correct. Remember, they have to be in both the zero category and the husband category. So because that has to be the case, that has to be not only in this row for husband, but in this column for zero. That number specifically, as according to our table, is 172 people. And we're going to take that all over the amount of people that we surveyed here, which was a fresh 1,700. So now, this is what we're going to be doing here. 788 plus 425 minus 172, and take that over 1,700 here. And then we're going to get our final result here for what we're looking for. So let me go ahead and do that here at least. Okay. We get 1041 over 1,700. Now, what's that as a decimal, guys? If you guys have a decimal for that. That would be superb. What do we get here in this instance? What's our decimal, 4 decimal places sort of dude? 6124. Okay. Easy peasy lemon squeezy. All right. All right. Any questions about that so far? Any questions about that? I'm going to do one more example here, but this time I want you guys to go ahead and give it a try. I'm going to do one more example, not in the book, but again, using this same table here, okay? We're going to use this table here for a couple more problems that are not here in the book. So I just want to be able to show it off so that way you guys can see how that works. Okay, let's try this. This is my own example here, so this is not in the book. So let's look at the probability of one or wife. Okay, so I'm going to give you guys a minute. The probability of one or wife. So having one kid or the wife only works, according to this table. And then once you guys got your answer, just put that down in the chat, and then we'll see if you got it. Probability of one or the wife only works. Again, once you have your answer there, put your decimal thing. Make sure to round to 4 decimal places there, Clay, if it is. If it is, then that's fine. You can leave it like that. Okay. See what other answers people come up with. All right, there we go. All right, hopefully we get a few more answers in here. Hopefully, maybe we're getting the same thing. We're gonna see. I'm gonna wait and see. We see if we got it or not. Don't know. People that look like they're coming to a consensus. Give it like 10 more seconds here, and then I'll go ahead and get going with this problem. All right. Okay, let's go ahead and see what we got here. So let's take a look at it and see if our answer matches exactly what all of you have put down here. Okay, so first of all, we need the probability of 1 plus the probability of the wife minus the probability of 1 and wife. Okay, so let's count up the number of people in 1. The amount of people in 1 is 353, according to our table. The amount of people in the wife-only category is going to be 126. And we're going to subtract the amount of people who are both in the 1 and wife category, which is 17. I'm going to figure that out. That's going to be all over 1,700 at the end of the day. Find out what we get. So doing this out here, got 353 plus 126 minus 17. That's going to be a grand total of 462 over 1,700. And so we get 2718 is correct. Okay, good. All right, excellent. And you all are correct. Good. Very nicely done. Okay, any questions so far? We're going to move a little forward here with this, but let's see. Any questions so far? So hopefully you got a little comfortable with that. Alrighty. Okay. Alrighty. Okay, so we've talked about mutually exclusive or not mutually exclusive as well, using the general addition rule. Finally, let's talk about, at least in this section here, let's talk about number 11. All right, number 11 here, the last part here. What about in situations when we have and? What do you mean by that, Chioma? Are you talking about when we're trying to find out one and wife, for example? If I'm understanding your question here correctly, I just want to be sure to be clear about what you mean by that. Yeah? Okay. So what you can do here is, if you want to be a little bit more succinct about that, you can also use the power of algebra. You can definitely use the power of algebra here. So do you see, like here on the screen, Shioma, you see that we have the probability of A or B is equal to the probability of A plus probability of B minus probability of A and B. Now, you can do some algebra stuff here, and if you want to just exclusively find the probability of A and B here, you just switch around the positions here. That'll still be the probability of A plus the probability of B minus the probability of A or B. So literally, you just do it. You just kind of flip the positions around, and you can use the or to find and if you need to. So in this case, you can use or again. I know that seems a little strange to say. If we looked at again, if we go back here for just a second here, Chioma. Let me show this off here one more time. I remember you asking about letter C. Well, we went ahead and already found letter C, right? If I said, okay, what's the probability that did we have 2 plus and both, right? Well, we already did find it in the problem when we did when I accidentally did or here. That's 370. Again, that just reflects, hey, what's the probability of 2? Okay, where does 2 or what is 2 plus and both overlap? Well, we just found that. It has to be in the 2 category. It has to be in the both category. Well, the amount of people that are in both categories is 370 people are in both categories out of the full 1700 that we have here. And that's it. And then we just find the decimal equivalent here in this case. All right, and then we get 2176. All right, fine. Okay, so just to kind of show off there, as I say, that's how we do and. Again, I didn't have to go through A plus B plus minus or. I can just also find it using the table straight up as well. Okay. All right. Let's move on here to the next question, okay? So the last question here of this section is going to be number 11. What does complement mean and the rule of complements? What does complement mean and the rule of complements? So complement in the word in math language anyway means the word not. Okay, so that is the rule of complements here. It means the word not. All right, so if we take a look at the notation here, the notation here for complement is A, and then we have a C here. It's kind of like an exponent, but really we read it as A complement, okay? Now, if we take the rule of complements, it's fairly simple. The probability of A complement here is taking 1 minus the probability of A. So essentially 100% minus the probability that A will happen here, leaving everything else left over. Okay, so that is essentially how the rule of complements will go. So let's take a simple example here. All right, and we'll see. I'll show you how this works. It's not too hard. Let's use our same table that we have here. Okay, so let's use the same table we have here. And let's say I ask you a question about complements now. And I ask you, okay, what's the probability that we don't have, that we have that we basically have not 0. Okay. So let's say we have the probability of not 0. So the way we would want to do this here specifically is we would want to take 1 minus the probability of 0. Okay. Now, trust me when I say this, the rule of complements is very, very helpful in a lot of different situations, especially when things are a little bit more abstract. The rule of complements is incredibly helpful. So basically, like this, it says, hey, what's the probability that we don't have 0 kids, from our randomly selected amount of people? Well, then we take the probability of having 0 kids, which is 788 over 1700, and then we're going to net our probability based off of that alone. You're going to see this concept here used in quite a few problems of complements here, so maybe not this simply stated, but still useful nonetheless. So if I do this out here, I get 0.5365. All right. Any questions about that so far? Any questions? No? Hopefully that's not too bad. Easy peasy lemon squeezy. Let's try another table. I know this table is a little boring, so we've used this table pretty much the whole time. Let's use a different table. All right, so let's use number 42. We'll use that table. A little bit easier. All right, so here we have, let's go ahead and read this out here for 42. And let's do this examples together. So 42, Harris Interactive conducted a survey in which they asked adult Americans 18 years or older whether they use social media, whether it be Facebook, Twitter, and so on, regularly. The following table is based on results of the survey. So I don't know how many of you use social media. Probably all of you use social media in some form or fashion. Probably, I say. I don't know exactly if you do or not. I would say, I know this poll probably is a little older. I think most people use social media. Maybe you have an Instagram account, and just like, yeah. I have to, actually, I gotta ask this question. Oh man, now I gotta ask this question. Okay. Now I have to ask the question here. Okay, let's go ahead and why don't I have that actually? So weird. That's weird. I don't have a poll. Huh. Should have a start a poll. Start a prediction. Okay. Manage a poll. All right. I'm not sure why I don't have that. Anyway, let me start this. All right. I gotta ask this question because it's one that's really fascinating to me. Do you take pictures of your food for Instagram? I gotta ask this question here. Some people, everywhere you go, you take pictures of your food that you get at the restaurant for Instagram. You're like, boom, boom, boom. I gotta take. You like, man, this cheesecake looks amazing, and of course you shove everybody to the side. You're like, I gotta take pictures of the cheesecake. I'm like, okay, I totally get it. It's like, oh my god. I'm like, okay. Like my sister does the same thing every time. Taking pictures of all the food that she eats. I'm like, okay, that's great, but I want to eat the food, man. Most of you said no. 11 people said no. One said yes. Okay. What do you guys, most of the time, what do you guys take pictures of then for your Instagrams or your Facebooks or whatever you use for your story? Or you guys do, or actually, do you take photos, a lot or no? Or if you do use social media, what do you guys usually do? I'm actually curious. What do you do mostly on your social media if you have a social media account of some kind? As you can see on the bottom of the screen, I have a Twitter account, but I barely use it, but still it's there. I don't know, you guys tell me. You have an IG dedicated to your art? Okay, very good. What kind of art do you do, Angie? Pictures of friends and family? Photos of places you visit? Very nice. So most of the time is like just pictures of friends and family. I would take photos of myself. Painting, sculptures, and pencil paper? Very nice. Like anybody who can do art, man, that's amazing to me. Art is tough for me. Ain't gonna lie. Man. I know most people go on Twitter or do something. Sports and pictures of anything? Mostly your baby niece. Mostly your baby niece. I see. You know how it's going to be, Skinny? You know how it's going to be like 10 years from now when your baby niece is like 10, 11 years old? It's going to be like, let me show you like these 5,000 pictures I got, of you when you were born. Like, I just remember you from way back when. Like, and you get the. You use it like, I'm going to show your friends how cute you were back then. Like, here you go. Like, that's perfect. The best you could ever be. Like, I rarely use pictures on my phone. Like, I don't know. I probably should take more pictures on my phone, but I don't know if you could already tell, ladies and gentlemen, but I am not the most photogenic person known to man. Not at all. My face may look decent, but the rest of my body, eesh. Too much Taco Bell and Pizza Hut later. Or actually, I don't even eat pizza. Yuck. Pizza's disgusting. I'd rather go eat Domino's. Um. Hey, Palabro. Good to meet you. Good to see you. I felt that on a deep level. I was looking at myself. I'm like, I'm the chubby chubs man. It's like, okay, that's fine. That's fine. I like, I understand that when I wake up in the morning and I stare at myself in the mirror, that my mirror once again is just going to, just that slight bit of large fragmentation of pieces of glass that will appear in my sink out of sheer horror, out of my own visage of its glorious ugliness that is the rest of my face. Like, okay, that's fine. Everybody has an opinion, and apparently my mirror every morning has that same opinion. Like, that happens. Like, it happens. It's okay. Don't feel bad. Your opinion, in my mind, is correct about myself. No problem. Oh, man. Dude. All right. All right, let's take a look here at. Let's look at this first one there. Probability. The concept is pretty easy, but very useful in real life, and this is very true, Palabro. Very useful indeed. Let's look at this one here, ladies and gentlemen. What's the probability that in this particular sample, we do not have a randomly selected person that is not 35 to between the ages of 35 to 44, according to this table? What's the probability? Thank you, Palabro, for the follow. I appreciate that, my friend. What's the probability that we do not select the random person that's between the ages of 35 and 44, according to the table here in number 42? What do you guys think? Tell me, help me. I don't know. I'll give you guys a minute to think about it. How do I set this problem up here? I'm going to have 1 minus what? What should I have here, guys? One minus 125 over 530. That is correct, Chioma. That is correct. So the probability of 35 to 44, yes? 100%. All right. Good, good, good. Right? So it's a lot easier for us to go ahead and find this probability from the perspective of finding out how many people between the ages of 35 to 44, taking them away and leaving everything else. All right? 100% true. And so what do we get here? What's our decimal answer here? What's our decimal answer for this? I 100% agree with Ollie here. 7642. Okay. Yes. 7642 is absolutely correct. Very nice. Very nice. Easy peasy lemon squeezy, ladies and gentlemen. Easy peasy lemon squeezy. All right. Any questions? Any questions at all? Any questions at all about complements or probabilities with ors and ands? At least this is the first part here of ors and ands and whatnot. Hopefully that stuff there is not too hard. I hope not, anyway. Twitch should include a latex extension for the chat. You know, that would be cool. I would not disagree with that. I would not disagree with that at all. I've been able to, honestly speaking though, Palabro, I've been able to work around it without too much trouble. So, fortunately, there's a lot of different ways you can kind of work around it as best as you can. But yeah, actually, it wouldn't be too bad. The problem with latex is just it's very, latex is pretty memory intensive. So, because you have to have a lot of pre-built functions and be able to automatically format them once you type them in. So My biggest fear would be if it slow down. It would slow down the chat a bit. But if you could seamlessly stream it in, then it'd be like that'd be cool as hell. I ain't gonna lie. Latex would confuse hell in you streamers. Yeah, that's true. That would definitely be true too. But there's but to be fair, and I'm gonna give it its due course. There's always a learning curve to everything, and that learning curve can be very high or very very low. So you could have like a little training thing to kind of go along with that, like about how to use it on the basic, and then if you want to use advanced functions, then you would have like again a little bit more help too for advanced functions. So, and Palabro, this is a class, my man. We are inside a college statistics class, actually. This is a real life class that is happening on Twitch. I know you're probably like, no, really, this is a real life class. Anyone's welcome, by the way. So you do not have to feel like you touched on toes, trust me. Anyone and everyone's welcome at any time. So any questions about section 5.2? Any questions about section 5.2? Hey man, anytime. Anytime. I stream three times a day, so I'll be here till 5:15 ish. Well, depending on how fast this goes. Then I have one at 6 o'clock as well. So I teach like 3 times a day, Tuesdays and Thursdays this semester. So yeah, absolutely, Julie. Absolutely, 100%. Okay, let's do another one. Okay, I can get behind that. Okay, I can put it up here. Okay, what is the probability? So let's do one more here, Julie. One more for compliments. What's the probability of that this randomly selected person does not use social media? So, Julie, can you tell me how you define this? How would you solve for this here? Actually, actually, I take that back. Hang on. That's a poor example. Let's try it this way. I just realized I used the actual wording from the problem. That's pretty bad. Okay, let me try it this way. That was pretty stupid. All right. That was stupid on my part. Okay, yeah. Let's do that one. How about not let's see. Okay. Can you tell me the probability of not using social media and being 45 to 54? So not using social media and you're 45, between the ages of 45 to 54. So the way you would want to do this here specifically is you just want to go ahead and you want to just remove the probability of people who use social media and are 45 to 54 years old. Okay. All right. So what's the probability that you use social media and you're 45 to 54 years old here, Julie? Can you tell me? What is the probability that you use social media and are between the ages of 45 to 54 in this particular table? Okay, very good. That's right. Very nicely done. That is absolutely correct, Julie. All right, so 83 people are between 45 and 54 and use social media. That's right. Absolutely spot on. And definitely over the 530 that from the total there. Good. So this is all you're going to enter into the calculator. Is you're going to enter exactly that. 1 minus 83 over 530, and then all you need is just the decimal equivalent there. So we're going to get 0.8434. Okay, that's what you should get there for your final result. And if you got that, then you should be good to go. Any questions about that? Of course. Yeah, anytime, guys, you can ask me to do another example if you're not sure. That's perfectly fine. This class is taken at your pace, not my pace. So I try and get things done. I have certain agendas to take care of, but if I don't only get through one section, like today, then I only get through one section. And it happens. So it happens. So no biggie, no big deal. All right, any more questions before I guess we head out for the day? Because effectively, I don't want to start the next section because there's only 5 minutes left, so. Hopefully everybody's all right. Okay. Oh, all right. Go to the big screen here. Bada bing, bada boom. All right. Well, that's going to take care of section 5.2 in a nutshell. We're going to be using these concepts here, of course, in the next section. In the next section, we're going to talk about the general multiplication rule. And the following section after that, which section 5.4, there's like 4 or 5 sections. I think 5 sections, but that's going to be conditional probability. So these tables that you see here that we worked on today in number 40, number 42, these are what we call contingency tables. We're going to see these guys also in the next section or two as well. We're going to use those once again. So just just setting ourselves up for looking at a few more examples. We'll look at different examples, of course, that may not have these tables. But you'll see types of problems here that use these tables sometimes. So good idea to just kind of start introducing that just a smidge. All right. Okay. Well, if we're all right, I think we're done here for today. I want to thank everybody for coming on out here to the stream once again. All of you are absolutely fantastic people. All right. I hope everybody has an absolutely great weekend. All right, we will be back here, same time, same place on Tuesday. I'm going to be back, of course, streaming in about 50 minutes or so. I'll be back here at 6 o'clock Central Time, so just at the top of the hour. I'll be back on here for my next 102 class, for those of you who are not aware about that. But for those of you who are in my class, I want to thank you all. You guys are absolutely fantastic. I love all of you. You guys, let's make this super enjoyable. Make it super fun. Thank you so very much. All right. Hey, thank you, Anna. I really appreciate that. I hope hopefully we win on Sunday because our team is like, oh boy. All right. If you guys, I'm on Discord or I'm on email. You guys know exactly where to find me here. All right. Thank you very much for the birthday wishes. Thank you so much. I appreciate that. I hope you guys have a lot of fun this weekend. Again, Don't forget, okay, do not forget that the test and the homework is going to be due there on the 23rd. So that is 1 week from today. So 1 week from today, make sure you finish up all the homework and the tests there. That way you get full credit for it, okay? And make sure to save before 11:59 on the 23rd so you get that saved credit, okay? All right. Good luck, everybody, if you're doing your test over the weekend. In the meantime, though, enjoy your weekend. All right? Have a great one. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right. Take care, everyone, and we will see you on Tuesday. All right. Have a great one, everyone. We will see you later. All right. Take care. Bye. Bye, everybody.